All right, I'm back. I'm ready to do it again. Remember last time I did this? I used this much acid. It was like almost 40 milliliters. Took me forever to boil it. Took forever for it to react. It took forever to boil it, and I spilled half of it right here. You know what I ended up with? I ended up with a 19% yield. I got 19% of what I should have got. So I'm back again. I thought about it, and I'm doing a few things different today. First of all, I'm going to clamp it in place. I didn't like this clamp because it made me feel uncomfortable. When you squeeze that, all right, I just feel a little uncomfortable. It's very easy to slip out. So I decided to go with the utility clamp this time. All right, clamp this in place really good. That way we can see the reaction. Then I've decided to go, again, I stuck with this. I've got 0.25 grams of magnesium metal in there. All right, this is the magnesium metal. See how silvery it is? It's a nice little ribbon of metal. 0.25 grams of it in here. Now, I've done the calculation, and with 0.25 grams of this, I should be getting 0.98 grams of my product. Remember, this is going to react with the acid that I'm going to add. So it's going to react with the acid, and it's going to produce magnesium chloride, which is what I want to produce. Now, I'm theoretically expecting to get 0.98 grams. So we're going to see how well I do today. All right, so here we go. I've got the acid here. I'm going to add the acid this time, and hopefully you can see the reaction this time a little more vigorously than last time. Whoa. Let's see if we can zoom in close on that. That's going pretty good. Yeah, that's going pretty good. And it's very, it's really hot. I mean, this thing is really going. And I've only added that much acid. I've gone with an acid that's 10 times stronger. All right. So last time my mistake was that I had an acid that was only 1 molar concentration. This is about 10 molar concentration, 10 times stronger. It means I can use less acid and get all of that magnesium to react. And it should react quicker. And actually, you see it's producing quite a bit of heat. I mean, up here, there's all kinds of steam coming off. It's getting so hot that some of the liquid is evaporating. And it's fizzing, going really good. I may not have to use all of this. I might be able to get away with I've only used about 5 milliliters, okay? So I was going to use 10, but I might be able to get away with just 5, which would be even better because then I have less liquid to evaporate, which means I can get my experiment done quicker and maybe do another time. Oh, well, I'm looking at that, and I've used just a little more than 5 milliliters of hydrochloric acid. All right, concentrated hydrochloric acid. This seems to be, and let me take this out. Let me show this here. Seems to be all gone, the metal. Walking around here. Yeah, it's very hot, and it's all liquid. There's no metal there now. Yeah. So, I'm ready to evaporate. I got my liquid. This time, I'm going to hold it this way. All right, I've got my lab burner down here. Let me put this back, clamp this back in place. The other reason I like this is because then I can clamp it in place and just let it cool off. All right. Oh, before we get going, let me tell you what I've done. Now, this is the data that I collected before today. All right, so the mass of this test tube, I did mass this test tube, and it's 34.75 grams. Then I added the magnesium to it, and it's exactly, believe it or not, 35.00 grams. That is really, that means you've got 4 significant figures there. Those zeros count because that was what it read on the scale of the laboratory balance. So that's 0.25 grams. If you subtract those 2 numbers, you'll see that's 0.25 grams. So we're going to heat this up. We're going to evaporate off the liquid because our compound is there. The magnesium atoms have reacted with the acid. The hydrogen portion of the acid reacted away. That's what all that fizzing was that hydrogen gas coming off. The magnesium metal, as it dissolved, you might say, kind of like was getting eaten up by the acid. The magnesium part combined with the chloride part of the acid, because this is hydrochloric acid, and it's forming magnesium chloride. Except we can't see it. It's dissolved in the water, in the liquid. So we'll evaporate off the water, and we should have a white solid, which will be our magnesium chloride. And as I said, I'm expecting to get 0.98 grams. According to my stoichiometric calculations, that's what I should get. So let's see. Gonna turn on my lab burner. Last time we did this, it took, let's turn on the gas for sure. Okay. Yeah, last time it took over 16 minutes, almost 20 minutes for me to have, 16 minutes I think it took about, for me to just get that magnesium those pieces to react. This time it reacted must have been under a minute or two. All right, so now I've got just this little bit to evaporate off. All right, so I'm going to take this off and bring it over here. And remember, I had so much last time. I had so much liquid. It was way up here, and that's where I had the problem. It splashed out. So now I've got very little liquid. So I'm going to heat it more gently up in here. All right, I like control of this now. Ooh, you can hear that. So I'm just going to stay around the top, just above the flame. It's hot up there. All right, it's already hot as it is, so it's not going to take much to get it even hotter. Now you can see it's starting to boil. Yeah. Look at that. Yeah, you can, I don't know if you can possibly see it there. The steam's coming out over here really good. Move over here a little bit. Yeah, nice. Going nice. Let me see if I can turn it around here so you can see it. Use my other hand here. You see the steam coming out. Hard to see with that white background. I can see. That's why I'll try to stand behind it. Yes, that's going good. Going really good. All right. I think we may get it today, but we won't know until we finish the experiment. So, heat it up. So as I said, last time, I tried it. I thought I could get away with using that concentration of acid. And it just took too long. 26 minutes, and I didn't use all that. Remember, I poured some of it out just so I could show you the little bit of magnesium chloride that was in there. All right, so, yeah. This time, I decided stronger acid. It's a little more, you have to be a little more careful. You have to be cautious. All right, you got to really pay attention. That's why I feel more comfortable with this clamp on there. It's got it really clamped in place really well. And I don't know if you can see some white residue up in here. You see, that's some of the area where the liquid evaporates away the salt. Magnesium chloride is a type of salt. It is a salt. Right. Salt is a compound that has a metal and a non-metal. Metal here is the magnesium, and the non-metal is the chloride. It's going pretty good. Notice how the yellow is kind of gone. That yellowish tint there was the hydrogen chloride that was in the water. Oh, now we're going. There we go. There we go. I'm going to come up here, and I want to heat up here because I got lots of condensation up there on the edges of the test tube. And I want to make sure I get that away because what I'm interested in is how many grams of this white compound have I produced? Right? So I need to evaporate away the liquid. And now I'm going to turn it the other way here. With this, I can actually use my right hand a little bit better. Even though I'm, got to be careful. I'm too close to the jaw there, and it's almost lit on fire. Got to watch that. This is a plastic coated jaws, which is nice, but they also, you can't get too close because if the fire gets on it, gets too warm, it'll start to melt, start to catch on fire. Plastic is very flammable, which means it burns very easily. Well, I see some moisture up here, so let me see if I can get this part right here. I want to heat up over here, just because it's kind of hard to get to the top. And let me turn it this way, heat the other side. Just gotta get the heat going there. I can see the condensation evaporating away. It's looking good. Let's give it a little more shot of heat just to be sure. And I'm looking, I don't see any steam coming off, which would be evidence that you're still evaporating some stuff. Looks good. So let's turn off the gas. Let's clamp this back in place. And you know what we could do for fun if you want? We can do it while is we can watch this. It's cool. It's cooling off right now. So that's our product. And hopefully in a few minutes, we're going to be able to get the mass of that. And then you can do the calculation to see how many grams did I actually end up with. Now, what we did here is we used the law of conservation of mass and the balanced chemical equation for this reaction. I think you remember from last time that we took magnesium metal plus hydrochloric acid, HCl, and formed magnesium chloride. So, looks something like this. We have magnesium. Let me write it down here for you. Yeah, I didn't plan it. I just thought of this right now to show you. 2HCl, those two, MgCl2, and hydrogen gas. So this is the balanced chemical equation we have right here. So we had 0.25 grams of that. We had plenty of acid. In this reaction, it takes two of these hydrogen chloride molecules to react with just one of those magnesium atoms. This is what we made. This is the white salt. This is hydrogen, which is all that bubbling that you saw going on. That was the fizzing. Hydrogen's gone. The water is gone, so now we have this white solid. This was a silvery metal. Now we have this white solid that contains magnesium and the element chlorine that came from the acid part. So we know we have 0.25 grams of this. So we use stoichiometry. We use this balanced equation. We figured out, and what you're going to figure out is, for the 0.25 grams of this, how many moles is that of magnesium? All right? And so you'll know how many moles of magnesium I started with in the test tube. Then we heated it, or after the reaction, we ended up with, we can now figure out how many grams of this do we have. Now, if we started out with 0.25 grams of this, we can see from the equation that for every 1 mole of magnesium that reacts, it's producing 1 mole of magnesium chloride. When I say 1, I'm referring to the number that is in front of each of these chemical formulas. Well, there wasn't a 1 there, but it was just sort of automatically understood that we already had 1 of them. We have 2 of these, and there's 1 of these. So for every 1 mole of this, we get 1 mole of this. So the moles of this magnesium will be equal to the moles of magnesium chloride that I get. And once I have the moles of magnesium chloride, then I can use the molar mass of that formula to figure out what that would be in grams. And I think when you do the calculation, you'll find out that it's about 0.98 grams. You can check me on that. Now, that 0.98 grams, which is what we're expecting to get, if this is what we get from the 0.25 grams that we started with, then this is what we call the theoretical yield. It's, in theory, what we should be getting. What we actually get, we'll find out once this is cool. Still a bit warm. I can touch it, I can hold it, but it's just a little too warm to measure the mass of it right now. But once I get the mass of that, Then all I got to do is take away the mass of the test tube, and I'll know how many grams of that I have. And how many grams I get of that actually, that's called my actual yield. So this is what I should get in theory. If everything goes well, I use my experiment well, I should get 0.98 grams, according to the law of conservation of mass. But the actual, that's what matters. So your percent yield is, what we do is we figure out, you take your actual yield, what I actually get, and I divide it by my theoretical, and then multiply that by 100, and then we'll see. Last time I said I got under 30%. I got like 20%. Actually, now that I think about it, I remember I poured off 2/3 of the liquid because there was still so much to boil away. So I just said, here, I just want to show you this little much. So, yeah, well, all right. Let's see what we got here. That's cool enough. I can mask that now. So let me unclamp it. Remove my lab balance. Okay. And what I did here, let me get my, I used a beaker to hold the test tube. Okay. Before I did that, let me zoom back here a little bit. So you can see. Before I did that, here's my lab balance. I put the beaker on the lab balance. These electronic lab balances have what's called a tare button. So I press that. Right now, the beaker is mass, again, 99.06 grams. But if I press the tare button, or zero button, it's now set at 0. So the beaker weighs nothing. So now all I have to do is put this on, get the mass of it, 36.06 grams. 36.06. Let me just double check that. Tare it. Yep, 30.6.06 grams. So now, there you go. There's the data. So now you can take that data and you can calculate how many grams of the actual did I get actual yield. How many grams of that? And use the formula that is on the sheet with this assignment to figure out the percent yield of this reaction. So you figure out the percent yield, and then also I need you to verify and make sure, do the calculation to make sure that I calculated correctly, that this 0.25 grams will indeed, lead to 0.98 grams of magnesium chloride. Okay, so good luck, and I look forward to seeing your results. So have a great day, and it's another great day in the lab. Bye. We got it.